Hello everybody, today we're going to be looking at exploratory data analysis using pandas. Exploratory data analysis, or EDA for short, is basically just the first look at your data. During this process, we'll look at identifying patterns within the data, understanding the relationships between the features, and looking at outliers that may exist within your dataset. During this process, you are looking for patterns and all these things, but you're also looking for mistakes and missing values that you need to clean up during your cleaning process in the future. Now, there are hundreds of ways to perform EDA on your dataset, but we can't possibly look at every single thing. So I'm just going to show you what I think are some of the most popular and the best things that you can do when you're first looking at a dataset. The first thing that we're going to do are import our libraries. So we'll do import pandas as PD. We're also going to import Seaborn and Matplotlib. Now, during this exploratory data analysis process, I often like to visualize things as I go because sometimes you just can't fully comprehend it unless you just visualize it, and it gives you a larger, broader glimpse of everything. So we're going to import, and let's do Seaborn, as SNS, and then we'll import matplotlib.pyplot as PLT. Let's run this. That should work. Okay, perfect. Now we need to bring in our data set. So we've worked with that world population data set. That is the exact one that we're going to use now. So we'll say DataFrame equals pd.read_CSV. We'll do R, and we'll paste in our CSV. And this is what it should look like, although your path may be different. Be sure to make sure that you have the correct file path. And then we'll read it in. Now this data set should look extremely familiar if you've done some of my previous pandas tutorials, but I did make some alterations to this one. Took out a little bit of data, put in a little bit of data here and there to change things up, because if it was just exactly how I pulled it, which I got this data set from Kaggle, if it was exactly how we pulled it like we've looked at in the previous videos, it's too simple. You know, we wouldn't actually be able to do some of the things that I would like to show you. So be sure to actually download this exact data set for this video because it is a little bit different. But what we're going to do now is just try to get some high level information from this. Now, if yours looks just a little bit different, like your values are in scientific notation, I have applied this so many times. I think it's, still applied to this. You can do something, and we'll write it right down here. We're going to do pd.set_option. And we'll do an open parentheses, and we'll say display.float_format. And so we're going to change that float format by just saying lambda x : and then we're going to change basically how many decimal points we're looking at. So let's just do here. So we'll do a quote, %, 0.2f. So we're formatting it, 0.2f. So we're going to format it, and we'll do %x. This is going to format it appropriately. I can run it, and actually it will change it because this is at 0.1, because I believe last time I did it. So let's run this, and then let's run this again. It'll change it to 0.2, so that's 2. I like it at 0.1. We don't really need it well, let's keep it at 0.2. Why not? We're going to keep it at 0.2, but that's how you change that. And I like looking at it like this a lot better than scientific notation. So just something to point out. Let's go down here. And let's just pull up DataFrame. So we have this data. One of the first things that I like to do when I get a data set is to just look at the info. So we're going to do .info. And this gives us just some really high level information. This is how many columns we have. Here are the column names. Here are how many values we have. And if you notice, this is where it kind of gets. So we have 234 in each of these. So in each of these columns, we have 234 until we get to this 2022 population. Once we get there, we start losing some values. And then at the world population percentage, we have all of our values, all 234 of them. The count tells us that it's non-null, so it does have values in it. And then we also have the data types. And these come in handy later. And these are really great to know. And we'll be able to kind of use those in a few different ways later on in this tutorial.
Really quickly, I wanted to give a huge shout out to the sponsor of this entire Pandas series, and that is Udemy. Udemy has some of the best courses at the best prices, and it is no exception when it comes to Pandas courses. If you want to master Pandas, this is the course that I would recommend. It's going to teach you just about everything you need to know about Pandas. So huge shout out to Udemy for sponsoring this Pandas series, and let's get back to the video.
The next thing that I really like to do, and this one is df.describe. This allows you to get really a high level overview of all of your columns very quickly. You can get the count, the mean, the standard deviation, the minimum value and the maximum value, as well as your 25, 50, and 75 percentiles of your values. So just at a super quick glance, there is a row somewhere in here, and this country, their population is 510 for 2022. And in fact, if you go back to 1970, it was higher. It was at 752. That's just interesting. Then if we look at the max population, one has 1.42 billion. I believe that's China. And then over here in 1970, we have 822 million. Again, I still believe that's China. But this gives you just a really nice high level of all of these values or all of these different calculations that you can run on it. And we can run all of these individually on even specific columns. But it's just a nice high level overview. One thing that we just talked about was the null values that we're seeing in here. I'd like to see how many values we're actually missing, because that is a problem. We don't want to have too many missing values or could really obscure or change the data set entirely. And so we don't want that. So we'll say df.isNull, and then we'll do a parentheses and we'll say .sum. And when we do this, .sum. There we go. When we do this, it's going to give us all the columns and how many values we're actually missing. Now we have 234 rows of data. So we have 41477555424. So we definitely have data missing. What we choose to do with it in the data cleaning process, maybe we want to populate it with a median value. Maybe we just want to delete those countries entirely if the data is missing. I don't think you're going to do that, but these are things that you need to think about when you're actually finding these missing values. This is what the EDA process is all about. We want to find different either outliers, missing values, things that are wrong with the data, or we can find insights into it while we're doing this as well. So this is definitely something that I would consider when I'm actually going through that data cleaning process. Really, really important information to know. Now let's go right down here, go to our next cell. Say df.unique. And this is going to show us how many unique values, and it's actually n unique. This is going to show us how many unique values are actually in each of these columns. And this one makes the most sense for continent, because I think there's only 7 continents, right? But we have 6 right here. And for all of these, each of these ranks, countries, capitals should all be unique. That makes perfect sense. As well as these, these populations are such specific numbers and such large numbers. I would be shocked if any of these were similar. And then for these world population percentages, it's much lower. And again, that makes a lot of sense, because when we're looking at, and we'll pull it up right here, when we're looking at these world population percentages, a lot of them are really low, 0.00, 0.01, like this one, 0.2. There are a lot of really low values for those small countries. And so those are all, one unique value. Now, let's say we just have this data right here and we want to take a look at some of the largest countries. And we can easily do that. We could say max and take a look at the largest country, but I want to be a little bit more strategic. I want to be able to look at some of the top range of countries. And we can do that based off this 2022 population. So we'll say df.sort_values. This is how we sort and not filter, but order our data. So we'll do sort values, and then we'll do by is equal, and then we'll specify that we want this 2022 population. And then we're going to say comma, and we'll say, actually, let's just run this as is, but we'll do head, because we just want to look at the top values. So now we're just looking at the very top values. So what we're looking at is actually these 2022 population. That's what we're filtering on or sorting on basically. And we're looking at the very bottom values because it's sorting ascending. So from lowest to highest. So this Vatican City in Europe is, 510. That's the value that we were looking at earlier. Now we can do comma ascending equal to false because it was by default true. We can do false. Whoops. We can do false, and then it'll give us the very largest ones. So if we just take a look at the top 5 largest by population, we're looking at China, India, United States, Indonesia, and Pakistan. And we can even specify that we want the top 10 in this head. We can bring in the top 10, and we also have Nigeria, Brazil, Bangladesh, Russia, and Mexico. And you can do this for literally any of these columns, whether you want to look at continent, capital, country. You can sort on these and look at them, and you can even look at things like growth rate, world percentage. This one seems really interesting. Let's just look at this one really quickly before we move on to the next thing. If we look at this world percentage, just China alone, I believe, just China alone is 17.88% of the world. So 17.88 and 17.77, and that's China and India. And those are very large countries with a high population. That makes a lot of sense why that is the highest world population percentage. Again, just getting in here, looking around. That's all we're really doing. Now I want to look at something, and I have always liked doing this, which is looking at correlations. So correlation between usually only numeric values. We can do that by saying df.corr and a parentheses, and we'll run this. And what this is it is comparing every column to every other column and looking at how closely correlated they are. So this 2022 population, if we look across the board, it's very highly, this is a 1-to-1. This is highly correlated to each other. And that almost for all of these populations, they're very closely tied to each other, which makes perfect sense because for most countries, they're going to be steadily increasing. And so they're probably almost exactly correlated. But we can look at these populations, and if you look at the area, it's only somewhat correlated. And that's because in some countries, they have a very high population, but a small area, or vice versa, a small area and a very high population. So there isn't a 1-to-1 correlation there. But it's hard to really just glance at this and understand everything that's there. We could just visualize it, and it would be a lot easier. So let's go ahead and do that. Let's go down here. We're just going to visualize this using a heat map, basically. So we're going to say sns.heatmap and an open parentheses. And the data that we're going to be looking at is df.core correlation. And then we also want to say anote equals true. I'll kind of show you what that looks like in just a little bit. But let's do plt.show. And this will be our first look. And I need to say show, not shot. We can get a little glimpse of what it looks like, but this looks absolutely terrible. Let's change the figure size really quickly. So I want to make this much larger than it already is. We'll do plt.rcparams, oops, right there. Do an open parentheses. And then right here, we're going to do in quotes, we'll do figure.fig size. This actually needs to be in brackets, I believe. Just like this, not parentheses. And we'll say fig size is equal to, and now we can specify the value that we want. Let's do 10,7 and see if this looks any better. No, that doesn't look good. Do 20. Okay, that looks a lot better. And this is just a quick way because it gives you basically a color-coded system. Highly correlated is this tan, all the way down to basically no correlation or negative correlation even, which is black. So when we're looking at these 2022 populations, and these are our populations right down here on this axis, we can see that all of these are extremely highly correlated very quickly. Whereas the rank really has nothing to do. It's negatively correlated. It doesn't really have anything to do with it. Then for the population and the world population percentage, it again is quite correlated except for the area, density, and growth rate. So I find that really interesting that, the density, the growth rate, and the area aren't really all that associated or correlated with the population numbers. That is, I kind of would have assumed that on some level they went hand in hand. The area does, which, again, makes sense, larger area, larger population, that kind of thing. But even density, I guess density and growth rate. Growth rate I can see because that's a percentile thing. That could be definitely not correlated. But I thought the density would be more correlated than it is. All that to say is this is one way that you can kind of look at your data, see how correlated it is to one another. That can definitely help you know what to analyze and look at later when you're actually doing your data analysis. Let's go right down here. Something that I do almost all the time when I'm doing any type of exploratory data analysis like this, I'm going to group together columns, start looking at the data a little bit closer. So let's go ahead and group on the continent. So let's look at it right here. Let's group on this continent because sometimes when you're doing this EDA, you already know kind of what the end goal of this data set is. You know kind of what you're looking for, what you're going to visualize at the end. That really comes in handy when doing this. But sometimes you don't. Sometimes you're just going in blind. And so far, we've really just been going in blind. We're just throwing things at the wind, kind of seeing some overviews, looking at correlation. That's all we've done. Now, I kind of want to get more specific. I want to have like a use case, something that I'm kind of looking for, not doing full data analysis, or not diving into the depths, but something we can kind of aim for. So the use case or the question for us is, are there certain continents that have grown faster than others, and in which ways? So we want to focus on these continents. We know that that's the most important column for this use case, this very fake use case. So we can group on this continent and we can look at these populations right here because we can't really see growth. You can see a growth rate, but the density per kilometer, we don't have multiple values for that. It's just a static one single value. Same for growth rate, same for world population percentage, but we have this over a long span, many, many years, 50 years of data here. So this, we can see which countries have really done well or which continents have really done well. So without, talking about it even more, let's do df group by, and then we'll say continent. Oops. Let me just copy this. I'm not good at spelling. We're going to say df group by, and then we'll do dot mean. And we can just do it just like this. And now we have Africa, Asia, Europe, North America, Oceania, and South America. Okay, so if I'm being completely honest, I knew most of these. All right, I'm no geography expert, but I knew most of these. I don't know what this Oceania is. I genuinely don't know what that is. So let's just search for that value and see. We'll come back up here in just a second, but I want to kind of understand what this is. So we're going to df, and we'll say continent. Let me sound that out for you guys. Then we'll do dot string dot contains. Oops, contains. Good night. And then I want to look for Oceania. And let's run this. Oh, I need to do it like this. Now let's run this. So now we're looking at our data frame and we're seeing when the values have this continent as Oceania. Okay, so these look like islands, I'm guessing. So we have Fiji, Guam, New Zealand, Papua New Guinea. Yeah, these look like all, I'm guessing based off the continent Oceania. Oceania. Guys, this is tough for me. Okay, I'm doing my best. This is part of the EDA process. I don't know what that means. I don't know what Oceania. Jeez, I'm just gonna call it Oceania. That's so wrong, but it's so easy for me to say. I now am seeing this and it looks like islands, which would make sense because for their average, they have the highest average rank. And I'm guessing that's because they're just mostly small continents. So let's order this really quickly. We're gonna do dot sort underscore values, do an open parentheses, and I want to sort on the population. We're just doing the average population. We'll do by equal. So on the average population, and we'll do ascending equals false. So when we're looking at this average or the mean population, Asia has the highest population on average. Then we have South America, Africa, Europe, North America, and then Oceania at the very bottom, which makes perfect sense. Again, small islands. World population percentage. So each of those countries in Asia makes up about 1% on average. Really interesting to know and just kind of look at this. And the density in Asia is far higher than almost double every single other continent. Really, really interesting, actually, now that I'm looking at this. But, that's something that I would actually look into. And I would be like, what is this Oceania or Oceania? What does that mean? And, let me look into that. Let me explore that more because I want to know this data set. I'm trying to really understand this data set well. But what I want to do now is I want to visualize this because I just feel like looking at it, it's hard to visualize. And again, the use case that we're saying is which continent has grown the fastest. Like it could be percentage wise, it could be, as just a whole on average. Let's take a look. So we're going to take this and let's copy it like this. Let's bring this right down here. So let's look at this. So if I try to visualize this, and let's do that. Let's do df2 is equal to, because I already know it's not going to look good just based off how the data is sitting. We can do df2. Oops, what am I doing? I don't need to do that, but I will. Okay, df2, and we'll do df2 dot plot. And we'll run it just like this. As you can see, Asia, South America, Africa, Europe, North America, Oceania. We can kind of understand what's happening, but these are the actual values that are being visualized, not the continents, which is what I wanted. In order to switch it, and it's actually pretty easy, and this is something that is good to know. We can actually transpose it to where these continents become the columns and the columns become the index. And all you have to do is say df2 dot transpose, and we'll do this parenthesis right here. And let's just look at it and then we'll save it. So now all of these columns are right here and all of the indexes are the columns. So let's say df3 is equal to, and I'm just doing that so I don't, write over the df or my earlier data frames. So now we have this data frame 3. So now let's do data frame 3.plot, and it should look quite a bit different. Whoops, I didn't run this. Let's run this and run this. And as you can see, this does not look right at all. And the reason is because we're not only looking at the correct columns. We have this density in here, word population percentage, rank. We don't need any of those. The only ones that we want to keep are these ones right here, this population. Now we can do that, and we can just go right up here. This is where we created that data frame 2 that we transposed. We can go right up here and we can specify within this, we actually only want specific values. Now we can go through and handwrite all of these, and by all means, go for it. But I am going to go down here. I'm going to say df.columns, and I'm going to run this. It's going to give us this list of all of our columns. And I'm just going to, you can just copy this, and you can put it right in here. I think I need a list with it. I think it needs to be like this. If I'm, let me try running this. Okay, so this worked properly. You can do it just like this, or a little shortcut if you want to do it like that. If you want to do a shortcut like, I would hope you would just do df.columns, just like how we looked at down here, except since this is an index, we can search through it. So we can just say 0, 1, 2, 3, 4. Okay, so we can do 5 up to 13, because I think it's 7. And we'll just, let's see if this works. It may not. I may actually need to go like this. Let's see. There we go. So you can just use, the indexing to save you some visual space, gives you the exact same output. So now we have this. This is our df2. Now let's go down and transpose it. So now we just have these populations and we have our continents right here. And then now we're going to plot it. And this looks good, although it's backward. Okay, it's backward. So what I actually want to do is not this. That is a quick way to do it, although not the best way to do it. So I'm actually going to copy all of these, and although I said it would save us time, it did not at all. So I'm going to put a bracket right here. I'm going to paste this in here, and I'm literally going to change these up. I might speed this up, or I might just have you sit through this because, this is an interesting part of the process and I want, you to get the full experience. You know what? Now that I'm talking about it, that is what we're going to do. You guys can hang out with me. This is a good time. We have 2010, 2015, 2020, and 2022. Now let's run it. What did I do? Oh, too many brackets. There we go. So now it's ordered appropriately. We have 1970 all the way up to 2022. This is how we want it. Let's transpose it appropriately. Let's run it. And now we basically have the inverted image of this. Now just at a glance, and we haven't done anything to this except for literally what we are looking at. At a glance, we can see that from 1970, China, Asia and China are already in the lead by quite a bit. And it continues to drastically go up, especially in the 2000s. Like right here, it explodes, like just straight up. Then kind of starts going up and just leveling off. Every other continent, especially Oceania, is just really low. It never has done a bunch. Let's see, look at green. Green has gone up from, let's say 0.1 up to about 0.2. So they've almost doubled in the last 50 years. And again, you can just get an overview, a high level overview of each of these, continents over the span of this time. So this is kind of one way that we can, look at that use case. We're not going to harp on that too long. I just wanted to give you an example. Like, when you're looking at this, sometimes you'll have something in mind of what you're looking for and you go exploring and just kind of find what's out there and find what you see. The next thing I want to look at is a box plot. Now, I personally, I love box plots. They're really good for finding outliers. And there's a lot of outliers. I already know this because the average, the 25th, 50th percentile are very low. And then there's some really just big outliers. But for your data set, it may not be that way. And those outliers may be something that you really need to look into. And box plots have been something that I've used a lot where I found those outliers that way and started to dig into the data to find those outliers and, came across some stuff that I'm like, oh, I have to clean this up. I have to go back to the source. Really, really powerful and useful to be able to find these. So all you have to do is df.boxplot. Yeah, let's take a look at it. And this already looks good as is. Maybe I'll make it a little bit wider. Let's do fig size. Oops. Sorry. Fig size is equal to, let's try 20 by 10. Okay, that didn't help at all. I apologize. I thought it would, but let's keep going. What this is showing us is that these little boxes down here, which are actually usually much larger because you have a more equal distribution of numbers or values. In the small value, this is where our averages lie. This number right here is the upper range. And then all these values, all these open circles, those actually stand for outliers. So we're looking at the 2022 population. There's a lot of outliers. Now, for our data set, knowing our data set is really important. Outliers are to be expected, especially when most countries or continents are small. So we're looking at, all of these little dots are outlier countries or outlier values, which each value corresponds to a country. So if this was a different data set, I would be, searching on these and trying to find these so that I can see what's wrong with them, if anything, or if they are real numbers. Like if this was revenue, everyone's revenue is way down here, and then there's one company that's making like $10 trillion, that'd be an outlier up here. And it would definitely be something that you want to look into. For our data set, knowing that, we're looking at population, this is more than acceptable and oddly enough. But that's what box plots are really good for, showing you some of those quartiles, the upper and the lower, as well as denoting these points that fall outside of those normal ranges for you to look into. So really, really useful. So now let's go down here, pull up our data frame again. And we've kind of just zoomed into the whole EDA process. There was one last thing that I wanted to show you. And this is the very last thing that we're going to look at. We're ending on really a low point, if I'm being honest, because the last kind of stuff was much more exciting. But there is something df.dtypes. Oops, let's do df.dtypes. and we'll run this. Now, just like info, it gave us these values, but we're actually able to search on these values now. So these object, float, and integer, we can search on those, which is really great because we can do include, equal, and we can do something like number. And none of these are numbers, right? Or none of them explicitly say number. But when we run it, I'm getting an error, series object not, oh, that's because I'm doing dtypes is for a series. We need to do select underscore dtypes. Now let's run this. Now it's only returning the columns in this data frame where the data types are included in this number. So you won't see any, country or any of those text or the strings. If we wanted to do that, we go in here and say object and run that. And this is another really quick way where we can just filter those columns to look for specific, whether it's numeric, we could even do float in here. And so now it's not including that rank, which was an integer. So we can specify the type of data type and it'll filter all of the columns based off of that, which, when you're doing stuff like this, it is good to know what kind of data types you're working with and look at just those types of data types, because there might be some type of analysis you want to perform on just that, whether it's numeric or just the string or integer columns within your data set. So again, ending on a low note, I apologize. Everything else that we looked at, all those other things that we looked at are all things that I typically do in some way or another when I'm looking at a data set. Exploratory data analysis is really just the first look. You're looking at it, you're going to be cleaning it up, doing the data cleaning process, and then you're going to be doing your actual data analysis, actually finding those trends and patterns and then visualizing it in some way to find some kind of meaning or insight or value from that data. And again, there's 1,000 different ways you can go about this. It does typically depend on the data set, but these are a lot of the ways that you'll clean a lot of different data sets. And so, that's why I went into the things that we looked at in this video. So I hope that you guys liked it. I hope that you enjoyed something in this tutorial. If you like this video, be sure to like and subscribe, as well as check out all my other videos on pandas and Python, and I will see you in the next video.